Hello everyone, welcome to my class. This is still Maths with Victor. Kindly like, follow, and share my Facebook page to all your friends and also subscribe to my YouTube channel. Today, I want us to discuss on something very important and very fundamental to mathematics, the place value systems. This is for pupils in primary school and students in junior secondary schools. The place value system is very important whenever we talk about numbers. So notice something on the board. We have two different numbers. The first one is 6,712, and the next number is 2,167. Two different numbers. But a careful look at these numbers should reveal a similarity or a peculiarity. You will notice that we have 6 here, we have 6 here. We have 7, we have 7, we have 1, we have 1, we have 2, we have 2. That means that these two numbers contain the same digits, yet they are different numbers. So the question is, why are they different? Why are they different? The reason why these numbers are different is that the digits that makes up the numbers are in different positions. 6 is here, 6 is here, different position. 1 is here, 1 is here, different positions. That means that the position of a digit determines the value of the digit. Therefore, the 6 and the 6 here are not the same thing. The 1 and the 1 here are not the same. The 7 and the 7 here are not the same. The 2 and the 2 here are not the same. What determines the value of these digits is where the digits are found, and that is what is called the place value system. The place of a digit determines the value of the digits. Let's talk about numbers. In mathematics, there are only 10 digits. Of course, we know that already, from 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the only digits we have in mathematics. So beside these digits, any other number is formed by combining these digits. For instance, after 9, the next number is 10. But 10 is not a whole new digit. It's a combination of 1 and 0. So we can get 23 while writing numbers. It's not a new digit. It's a combination of 2 and 3. So while dealing with numbers, there are cases where digits are found in different positions. And these positions determines the value of the digit. And that is what we call the place value system. And that is why this number is different from this number. So let's talk about their place value. All right. So when we talk of 2, the last number here, can I just quickly write this here? 2167. The last number here, 2, is in the value we call the unit. The unit. Unit means 1. So we can multiply 2 with 1, and that still gives you 2. That means this number is 2. 2. That digit is 2. It's the unit. Then this digit is in a value of 10. So it is not 1, but 10. All right? But this is in a value of 100. So this is not 7, but 700. 700. And finally, this is in a value of 1,000. So this is not 6, but 6,000. So we can split these numbers by writing these as 6,006. The rest becomes zeros. And then the next number, 7, the rest becomes 0. So we have 2 zeros. So we have 700. Then the next number, 1, the rest, only one number, becomes 0. Then the final number is 2. So these number and these are the same. So we combine these to form these numbers. So that is why you want to call this number, it is 6,000, because 6 is in thousands, not ordinary 6 as a single digit. 6,700, and because 7 is in 100. So the place value of 6 is 1,000. The place value of 7 is 100. The place value of 1 is in tens. Thousands, hundreds, tens, and then the place value of 2 is in units. So we can see that these numbers can be splitted out in their different place values, and you will have 6,000 710 and 2 is 12. So we can add them together, 0.002.176, which is still the same as this, place value systems. So we can look at the values of these numbers. Like I said before, this 2 is not an ordinary 2. It is in thousand, because after 2, the next digits, 1, 2, 3, becomes 0, 0, 0. That means 2 is in thousand. And therefore, this 2 represents 2,000. Whereas in this case, the 2 represents ordinary 2. You see why the numbers are different. The next number is 1, but after 1, there are 2 digits, they become 0, 0. This one is in 100. 100. So this one is not representing 1, but representing 100. 100. The next one is 6. But after 6, there is only 1 digit, which becomes 0. 6 and 0. That means this 6 is not representing 6, but tens. In tens. It means 6 times 10, 60, 6 tens. Then the last number is 7, which is there with no other number attached, is the last one, the unit. So for this number, we can combine these things together to produce this number, meaning that 2 is in thousand, 1 is in 100, 6 is in tens, and 7 is in units. So we can add up together 7, 6, 1, and 2. So you can see from this lesson that these 2 and these 2 are different. For here, the 2 represents 2,000. For here, it represents ordinary 2. For 1, in this case, it represents 100. For here, it represents 10, because it is in 10. It is in 100 here. For 6, in this case, it represents 60. It's in tens. For 6 here, it represents 6,000, because it is in thousands. And for 7, in this case, ordinary 7, for here, it represents 700, because it is in 100. And that is why this number is different from this number. So place value is very important, because it gives us the value of the digits in any number. So when we talk about place value, in summary, for whole numbers, because I'm dealing with whole numbers, subsequently, we talk about decimal numbers. So for whole numbers, the last digit is the unit. Is the unit. The last one, just like I've shown before, the last one is the unit, and then the next one is the tenths, and the next one is in 100, and is in 1,000. We can proceed further to tens of thousands, hundreds of thousands, thousands of thousands, which is millions, and so on and so forth. Thank you, and God bless you. I will leave you with this. 8, 3, 5, 4. So you tell me the place value of 4, the place value of 5, the place value of 3, and the place value of 8. Thank you.